Hello everyone, I am Lily. I am going to present on the superior antifouling and self-cleaning performances of UV light driver magneto hybrid polyoso-metallic composite membrane. This inventor got me, meaning Dr. M, Prof. Abdulatif, Dr. Siti Khatibul, Dr. Hu, and Dr. Chu. This is my presentation outline. I cover introduction, method, result and discussion, conclusion and intellectual property and publication. I would like to give you all some background information. What is the membrane separation process? Membrane separation is a technology which selectively separates material through a semi-permeable barriers and separate the component in a solution by rejecting unwanted substances. The membrane separation process is shown in this figure. In the membrane process, the thick string is split out into two types, which are the fraction that permeates through the membrane known as fluid, while the fraction consists of the consistency that has not been transferred through the membrane, usually known as retentate. A main challenge in membrane separation is the foiling. Foiling results from the depositions, absorptions, and/or accumulation of rejected species on the membrane surface. As a result, there is a decrease in recovery of flux, an increase in membrane clearance expansion, and a reduction in membrane lifespan. In order to reduce the volume of the membrane, directly incorporating hydrophilic materials such as HPOM into PS membranes, which is used for improving recovery flux and antifouling ability. On the other hand, if a new photocatalyst is added into the membrane, there will be a less photocatalyst on the membrane surface, and the self-cleaning ability of the membrane will be reduced. This is due to the presence of 20 photocatalysts hidden in the polymer matrix, which causes the membrane to have a low surface modification efficiency. Hence, by adding every 3 or 4 nanoparticles with the HPOM in the PS casting solution under a magnetic field to manipulate the particles onto the membrane surface so that HPOM can sufficiently display their antifouling and self-cleaning ability. Now I will move to the process on fouling mitigations of Magneto-HPOM and PS membrane. As we can see that a cream membrane of the new membrane during filtrations, it can separate the polymer solutions at the same time leaving the filings on the top surface of the membrane. After that, this membrane will irradiate under UV lamp with water cleaning. Then the radical will attack the film and convert them into photodegraded product. Next is the novelty of this invention. First is to produce composite membrane with a high surface modification efficiency using magnetic induced particle negation approach. Second is to develop an outstanding self-cleaning and antifouling properties of the composite membrane. Let's move on to method. Firstly, the HPOM function monomers and the Magneto-HPOM nanocomposite were synthesized. For synthesis the photocatalytic membrane, Magneto-HPOM PS membrane was synthesized by dispersing the Magneto-HPOM nanocomposite in PS cutting solution and with a magnetic field condition, and the neat PS membrane was also synthesized. Later, the properties of the synthesized membrane were characterized and evaluated of their reversibility membrane performance. The next topic I would like to talk about is result and discussion. Here is FTIR analysis. In the figure, you can see that the Magneto-HPOM PS membrane has a block peaks in a red dotted box, which are characteristic of Magneto-HPOM composite. Therefore, this analysis confirms that the successful incorporations of Magneto-HPOM PS membrane This slide shows the contact angle analysis on the preparing membranes. Shown in this table, the results show that the contact angle decreased when Magneto-HPOM and the composite was added into the PS membrane, which is membrane hydrophilicity. This attributed to the migrations of the nanocomposites to the membrane surface during the coagulation step under a magnetic field, which was the main factor contributing to the increased hydrophilicity of the Magneto-HPOM PS membrane. Next, UniMAP and reusability performance on Magneto-HPOM PS membrane. The anomalous flux of the synthesized membrane are shown in this figure. We can see that the membrane cubic flux decline and recovering are stable throughout the 3 cycle. The membrane shows the flux improvement during the reirradiation flux fluctuations, indicating that the hybrid membrane retains photoactivity and self-cleaning functions. Indeed, the Magneto-HPOM membrane retains HA molecule well, with a nearly achieved 100% rejections throughout 3 cycles. After the irradiation plus water chlorination in region B, the FRR value raised up to over or nearly 100% throughout 3 cycles, showcasing that the hybrid membrane exceptional self-cleaning properties. To conclude, with a magnetic-induced migration approach, the Magneto-HPOM membrane has excellent self-cleaning and antifouling properties. The Magneto-HPOM membrane in the reusability phase has shown excellent flux recovery and the ability to remove HA molecule will achieve 100%. So we have the copyright and also publish some research paper about these inventions. That's all for me. Thank you.